Hi and welcome. In this video, I'll be walking through the technical aspects of the prototype I built for the web-based platform. This demo is focused on showing how the system works under the hood, covering the architecture, the back-end logic, the front-end logic and interactions, and basically how everything comes together in the browser. So firstly, the stack, the system architecture and the tech stack. This website app is built using Flask for the backend and HTML, CSS and JavaScript on the front end. And the data is stored in a SQLite database for now, since this is a prototype, but the structure would support scaling to PostgreSQL if deployed. The folder structure follows a standard Flask convention. Under the app folder is the routes folder, static and templates folder, and then the init.py file and the models.py file. Under the routes folder, I've separated the routes into two: the authentication and the main. The authentication handles authentication logic like the sign up, the login, logout, OTP verification, and resending OTP and the forgot password route bar. This page is not functional yet. And then the main supports the main pages like the home page, the installation booking page, the consultation booking pop-up form, the Ajax endpoints for booking times, the booking info page, and etc. The static folder contains the CSS, images, and JavaScript, while the templates folder contains all the HTML pages on the website. CSS styles, JavaScript connected to some of the HTML pages. For the backend logic, let's just brush through each major feature. The booking form. For the booking, the form data is submitted via post and validated before being saved to the booking or the consultation booking tables shown here. Let me maximize this actually. Right here. And then for the consultation flow, a pop-up modal sends the form data directly to a separate table, and the tables are stored in the models.py. This form only submits confirmed consultations and not cancellations. On the front end, the JavaScript plays a major role in keeping things responsive and interactive. Let me show you just a few things. For example, on the home screen, let me go to the home.html too as well. We have a product carousel right here. And then this is the script for the product carousel slide. And this is to move the products to scroll. The booking form uses custom validation logic for the phone number, the date speaking using flat picker, and drop downs for available times. The book time slots are disabled dynamically based on the data fetched from the backend as shown. Here. For the carbon footprint calculator, it doesn't have any backend because it uses JavaScript for most of it. It calculates a score based on the assigned values in the HTML right here. Right here, these values are used in this to calculate the carbon footprint of each user. For the energy tracking page, it integrates data from a live energy API right here. So I fetch and process real-time carbon intensity data as shown, and also generation mix data, and also for the 24-hour trend data, to be honest. And then for the visuals, I use zinc chart to display a radial gauge for carbon intensity right here, and assign the values and the attributes. And then a 24-hour line chart to also show the carbon intensity changes right here. And then to show a pie chart for the generation mix I actually used chart.js for this one. I didn't use ZingChart. Right here. Sorry. The raw API response is passed in JS and then passed into chart configuration objects. Each chart is in its own section with a heading and description to help orient the users. Right here. And there's also a textual summary of the current data shown underneath the visuals right here. So overall, this is just a run through of the structure of the code, and especially the file structure and the architecture, and also the database. I used Flask Migrate to handle the database migrations in case I needed to downgrade or upgrade the database. I don't have to manually delete each time. And then I have a README file for third-party developers to read and how to run the program, and then requirements file to install all the libraries at once instead of one at a time. So overall, this system uses Flask to handle routing and data persistence. JavaScript is used for dynamic user experiences and for API-driven visualization for real-time environmental data. And the code base is modular and designed to support further scaling using Flask blueprints. This prototype is structured to grow with the project. Thank you for watching and have a wonderful time. No, don't say that. Let's rephrase. Thank you for watching. Stopping in 3, 2, 1.